and we're going to jump right into it. So we have Jean Botti, the CEO of VoltAero, and he's going to take us through his view on the industry and the aircraft that he's trying to develop. So Jean, I'll leave it over to you, sir. Thank you.
Thank you. I'm going to share my screen. Tell me if you see it. Can you see my screen? Yeah, okay. Okay, so listening to Neil, you know, there is not much I can add to that. I think he made a very good summary and assessment, you know, and I fully share his view, quite frankly. So I would say here what you see in front of you are two designs. One is our demonstrator that I will come back to it in a sec here, that we're flying right now, fully hybrid, you know, and we have tested 3 versions. Now we're at version 4, the 10 seats. And in the right side are Casio 2, which will be the future production aircraft, the one that will go into production, derived in 4, 6, and 10 seats. So remember these pictures because we will see them along the way. Well, if we look at the industry, and I'm not going to dwell too much into this because Neil just said it, okay? There's going to be a lot more environmental issues. You know, we're going to have to remove, even if it's sometimes a bad perception about, you know, aeronautics, but we're going to have to remove aeronautics from the environmental equation. And those issues are going to stay there. There's going to be also societal challenges like noise, pollution, connection to regional communities, you know, those are going to have to be without high-speed links, okay? And finally, you know, you got plenty of territorial challenges, and we heard about, you know, just before Gatwick and all that, and it's true, we have to use what we have better. Today, we don't use what we have, we don't optimize it. And this becomes even more important, you know, to the COVID-19 impact on aviation, because people, we want to make sure they are, you know, they don't go into the big, I mean, at least the population, some people there, we want to be able to go to airports in all safety, not crowded, you know, waiting 2 hours online and so on and so forth. So it's going to create some, I would say, new opportunities in specifically for general aviation. And if we look at that market, you know, it was, this market already in 2019 was valued at, you know, 24 billion, okay? And lots of aircrafts in the fleet, and a lot of old aircrafts in the fleet. You know, 360,000 piston airplanes have an average age of 44 to 46 years. So there is a big opportunity to start something with, you know, something new here. And I'm not going to go and say that, you know, a hybrid aircraft, I have seen so many times that written that it's going to be miracle. Electric hybrid in terms of total cost of ownership are going to be miracles. No, they will be competitive. They will be competitive with piston airplanes of today, but don't expect that the total cost of ownership, you know, will be drastically changed. I want to make that point because we see so many fake news on this. Anyway, Casio, with its modular design and performance characteristics, is really well positioned, you know, to take itself into this market. And we have 3 segments that I will, you know, expand on. First of all, if we look at technical objectives, this 4, 6, 10 seats, you know, is for general aviation. And it's going to have to replace, you know, fuel power vehicles, obviously. And it's going to have to have a better operating cost, but not huge better operating cost, emissions and noise. And it's going to enhance regional mobility, you know, by providing, you know, schedule on-demand air services for smaller airports. It's going to be also very good for postal services, deliveries, you know, medevac. This is going to be also extension of what we can do with our Casio. And we also, as VoltAero, as a company, we are expanding into powertrain development for other commercial application, in particular helicopters and UAVs. Our commercial objectives are, you know, to put the Casio, the 330, the 4 seats, into production by the end of 2022. And we're planning to be at a rate worldwide including Asia, and United States, obviously, by 2024 at 100 planes per year. I said it before, the target market, is regional commercial, FINAL operations, cargo, point-to-point, private and business aviation. It has to be a very competitive aircraft, but again, we have done all the simulation based on true flights, and true comparison between, apple to apple, and we have a cost of ownership that is lower, but it's not drastically lower. And in particular, it depends, of if you fly most of the time in hybrid, or if you fly in full electric, and if you start with charged batteries, or if you have to recharge the batteries on flight. So Didier S10 is my associate together with Marina Evans. We are 3 co-founders, and Didier was the one that crossed the channel when we did the historic flight in 2015. And before that, with Didier in 2011, we had also flown the Cricri, the smaller, it was a 20 kilowatt aircraft that was doing acrobatics. And then we went to 60 kilowatt aircraft with the EFAN, and in 2015, and now we're flying the 600 kilowatt airplane hybrid. So the Casio airplane, modular concept, dual source of energy, noise reduction, 200 knots cruise speed, which is very competitive in with respect to the competition. I'm thinking about the Cirrus SR-22, Cessna 172, 73, Piper. So those are the kind of airplanes we are up against here. Fuel economy and range. This, as I said, varies from your mission flight, if you want. You cannot say hybrid is that much less of a conventional. It doesn't work that way. You have to calculate each segment, and from each segment you have to go, am I in full electric, am I in hybrid, am I in mild hybrid or heavy hybrid? So that has a direct impact, and that's how you can calculate also your cost of ownership, being TCO or DCO. It's going to be in the category of CS23. It will have 3.5 hours of autonomy with a possible extension to 5 hours, range of 800 miles, and takeoff and landing distance less than 1,800 feet. And it will be able to land and take off both from, I would say, paved runways and also grass runways. Power, the 10 seats will have 600 kilowatt of power. The 6 seats will have 480, and the 4 seats will have 330. Those are all being validated into our Casio 1 prototype. I already spoke about the speed, and in terms of emissions, we can go from 20% lower in full hybrid mode to 100% if you have trips less than 200 kilometers. There you will fulfill your mission in pure electric. Our design and the concepts are all patented, and this concept of a dual source of power being series hybrid, parallel hybrid, pure electric or pure thermal has been something that provides unmatched safety, quite frankly, because we have multiple redundancies into the powertrain. It's compatible with biofuels. And in terms of noise, we are shooting for -4 dBAs as compared to conventional competition, with silencers, okay? If you take, for example, SR-22 with a silencer, we should be around 4 dBAs less than that. And no noise during taxi operations. There is no turning propellers in our airplane when it's in taxi. I talked about before about low cost of ownership. So it's what I call an airplane a la carte. Basically, Casio can, depending on the profile you have, if you are in the range of 0 to 200 kilometers, if you are from 200 to 600, 600 to 1200, you're going to use your airplane, and all of them can be used that way, the 4, 6, and 10 seats. You would do pure electric, you would do mild hybrid, or you will do heavy hybrid. And the configurations that we have done are all been studied to be able to fulfill, you know, these requirements there. And obviously, in each one of those segments, your fuel economy will be very different, you know, from baseline. So these are the airplanes that I was talking about before that, you know, we are competing with our Casio airplanes, and very conventional ones right now and very well known. As I said today, the fleet is getting very old, and it offers, you know, an opportunity for us to jump in. If you look, you know, when you look at the application by market, you know, you go from, if you look in red, those are the routes, number of flights, okay, daily flights that you get less than 1 hour. In gray, those are the routes between 1 and 2 hours, and it's a lot of flights, okay? So it means there is a lot of opportunities to fly between, you know, 1 to 2 hours, and even less than 1 hour. And that's why the application can be very different, dependent of the mission profile you have. Our timeline is to be, like I said, in production by the end of 2022 with the 4 seats. 6 months later, we go with the 6 seats, and 1 year later, we go with the 10 seats, excuse me. And right now, we are at proof of concept. You know, we're finishing Casio 1 completely, and we will have done all the testing of 4, 6, and 10 in terms of powertrain. And that test bed will continue to go to help us to develop Casio 2. I wanted to show you our airplane. So this is the flying airplane. And in the right side, there is, I would say, the Iron Bird, the one that we have done all the previous, you know, validations and modification before putting that in the flying plane. This is our version 3 that we just flew last week. We had special permission, you know, because we're confined with the coronavirus. A special permission to be able to still fly because it was for professional use and testing. And this is the test we have done on the 4 seats. And I would like to show you a little movie of these flights, one of them, because we did 50 flights with this airplane. So this is the 4 seats, 2 Safran engines, electric engines in the front, thermal engine in the back, and that was the, I would say, the low version. So now is the module. We're going to test now the 10 seats. Okay, it's already being tested, but I wanted to show what we're going to put in the back of this airplane. Is going to be a 600 horsepower hybrid module with 3 electric engines. So the total powertrain will be 600 kilowatt, 800 horsepower. That will be representative of 10 seats. Here we go. Pay attention to the gauges on this. Sorry, I had to do that again. So you can see we get to 600 horsepower on this hybrid rear power plant with 3 electric motors, and we will have 2 electric motors in the front. And this This is the right now on the test bench doing all the validations, all the mapping, and due to the coronavirus, you know, we had to obviously stop for a while, but we're back on track now, and we will fly this bird, the 10 seats powertrain, in July. So this is where we stand right now. So for us, if you want, the powertrain will be totally validated in all the versions, and as you can see, this will be the new design. And if you pay attention, this is the 6 seats. I'm gonna take my hero. If you look at the door, this door has a purpose, okay? It's not a small door. And that's why this modular aircraft will help us to develop many applications for the future. And that concludes my presentation.
That's brilliant. Thank you very much, sir. It's always interesting to see aircraft flying. Certainly miss it. I think, as you heard during the webinar earlier, when an aircraft flies overhead, I'm outside either with my noise meter trying to find out how noisy it is, or on flight radar trying to find out what's going on. So thank you very much for that. I'm aware of time, and we need to move on to our next presentation, but there's been some questions on the Q&A side. So by all means, if you feel that one's appropriate for you to answer, and I'd also invite the other panelists that were speaking earlier today to jump on. So thank you very much, sir.
Thank you. I'm sorry, I have Neil, I have to leave because I have another appointment. As you know, I cannot be part of the panel. I really apologize, but if you guys have some specific questions, don't hesitate to send those to me.
We will.
I'm more than happy to answer those, okay?
That's lovely. Thank you very much, sir.
Thank you.
Great. So we have Julian Renz, the business development lead at ZeroAvia, who's going to take us through developments there. However, I just saw something pop up on the BBC website, and apparently EasyJet are reporting that there's been a major hack of their databases, and a lot of their customers have had their personal details exposed. So you might want to keep a lookout for an email there, or check your credit card. So that's on the BBC News website. So a bit of a flashing information right now. But putting that aside, I'm going to pass quickly over to Julian and let him, yeah, great, perfect image, I think. And please, sir, take it away.
Thanks, Daryl. And thanks for the invitation as well, Eric, to speak again today after December. I wanted to start a little bit different today because obviously we've been talking a lot about the future in almost every panel that we had here today. And I think, you know, the past 2 months, probably like everyone had a bit of time for reflections. And so did I, and probably even more so did my cousin, who became a father 2 weeks ago on the 6th of May. A little daughter called Helen, and I had an interesting conversation with him that I wanted to share with you because you know, obviously it's crazy times at the moment, and having a kid in those crazy times doesn't make it stranger. But we started discussing, you know, the world that Helen will grow up in, and I think, you know, to put all these future conversations that we have been having now the last kind of 5 hours already a bit into context, it helps to think about, right, actually people that will use these products, these technologies that we've been talking about a lot. So what I want to do with you is do a couple of bets. And usually I would, you know, I will put out a bet and you can hold that bet. Usually I would ask you just, you know, raise your hand to bet with me. Unfortunately, that's not possible with such a virtual conference. But I think Eric can help me out and can pop up the betting questions, and we'll try to do a little live poll there. So think about it as a bit of a mind-opening exercise and putting things into perspective. And I promise this will be completely non-corona related. So my first bet is that Helena, and don't forget, right, she's born 2020. that she will never learn how to 10-finger type. Because essentially, you know, by the time she's 5, it's 2025, she'll be starting to talk to Alexa, to Siri, or whatever these voice assistants are called. By the time she's 10 and maybe, you know, starts doing something on the computer, I think that will be more or less obsolete at that point. And so really, I don't think she will ever learn how to properly type on a computer. And I bet you to bet against me. So Eric, can we pop up the first question? Let's see if that works.
The polls are just coming through.
You already had the polls. Huh.
Yeah, we're about a third of the way through people voting. So,
okay, just give me the question. Just give me the answer for the first question.
Okay, so the first question, it's hovering around 50-50 between the two. But yeah, of course, we still got a lot of answers to come in. Okay,
so we'll see how that develops. Because I like to, you know, it's always interesting to see the answer to these questions depending on the audience you speak to. So we're going to get to that in a bit.
Well, it's changing as you're talking.
Yeah, my second bet is, and I guess if you have the questions already in front of you, probably have my second bet already, is that by the time she's 18 and, you know, she would do her driver's license test, I bet that Helena actually will never do that. She will never get her driver's license. She will never learn how to drive. I think by that time, you know, autonomous vehicles, certainly on the ground, will basically be dominant. And don't forget, right, then we're talking about 2038 here. So again, if you already have the poll in front of you, please click. Otherwise, Eric, if you can put up the second question, and we can try that.
It's up and they're voting on it. And right now it's still pretty split, 53-47, saying yes, she will get a driver's license.
Yeah. The last time I did that was in front of a German engineering audience in Stuttgart, and I think I got like 10% of people agreeing with me. So I'm glad that I don't seem to be as crazy here. And then my last bet, and I like this bet because I heard, I think it was in like January or February, there was a study that between 18 and 30-year-old men and women in the UK, like the highest share of trips they do on a plane is actually for stag and hen do's. So my last bet is that Helen, by the time she gets married, and let's just assume, right, that is when she turns 30, so that's 2050, that she can actually fly wherever she wants to on a zero-emission airplane. And obviously, right, this is a bet that I will actually put to you only at the end of this little presentation, because clearly it is the bet that we at ZeroAvia have bet our company on. All the developments that we are doing is to get zero-emission aviation powertrains to the market. And just again, coming back to timelines, right? I was now speaking about 2050. The bet that we are making is essentially that you can have zero-emission aviation powertrains much, much sooner than that, before mid-decade. And I'll take you through our thinking there, what we're doing, how we're doing it, and why we think that is actually the most practical approach to really get sustainable aviation up in the air. Another nice slide I did want to share in the beginning, because it is kind of the usual one that I start out with, and obviously something that will by now be changed quite a bit. Because whereas, you know, last year aviation represented 22.5% of global emissions, that will certainly be different this year. But I think overall, you know, especially to the audience today, I think we can all agree, right, that aviation does not really have a solution today to lower their emissions, and does therefore have a risk of representing much more than those 2.5% going forward, as other sectors that do have a solution, like road transport, or like some of the industrial sectors, actually start to decarbonize. So the way that we think, right, the industry will get out of this crisis is actually by using renewably powered hydrogen electric aviation. And our role in this is what you see here on the right-hand side of the chart. Our role in this is the powertrain provider. So what we do is we work with leading suppliers that work with us on the fuel cell system, on the electric motors, on the prop pitch controllers and these kind of things. We integrate everything, and we work through with the airframe manufacturers, because we think the airframe manufacturers actually know how to build the airframes pretty well. And we work with them to then bring that product to the market. Obviously, even if we did have a product in the market today, right, it wouldn't actually be much use, because clearly to get hydrogen and electric aviation to take off, you also need to really think about the ecosystem that needs to be in place, the hydrogen production at the very least. And so the interesting, or the way that we think about it is, right, that you get not only the best environmental performance, but actually the best economic performance as well, if you employ localized generation of hydrogen through electrolysis. And because of the scale that sub-regional aviation can have, that becomes the most economically meaningful as well. What I do want to dive deeper on now a little bit is the bottom part of this chart, right? We're talking about longer range, lower cost, zero emissions. And the question that we always get asked, right? And we're by now like a 2.5-year-old company, is how does that all compare with the battery electric piece or the hybrid electric piece? And I just want to make one comparison to battery electric today. And if anybody's interested, right, how it compares to conventional turboprop or electric, we've done like extensive analyses on that and are actually going to be releasing a white paper on that in the next couple of weeks. So happy to dive deeper on this. But the general idea is, right, that what limits you in terms of performance on the battery side is clearly the energy to weight ratio. And that's where hydrogen has a lot of benefits. So you can get kind of 4 times the gravimetric energy density out of the system compared to the best battery system, and that even with gaseous hydrogen, which is what we are employing in our very first step. If you moved to liquid hydrogen, you get roughly another factor of 3 in range. And that is really just kind of the performance angle in terms of, right, I mean, range you can always kind of trade off with payload, so treat it as that. But even if you thought, hey, actually I do have use cases where battery electric might be better, and we think that in most cases hydrogen electric will still beat battery electric because of better economic and environmental performance. And as Jean said just before this, it does depend on the type of mission you fly, obviously. And we've done a lot of case studies for different airlines to actually really look in detail into their routes and look at what needs to be in place from a production point of view, but also what needs to be in place or where it makes most sense. But generally, right, you actually can get lower operating expenditures with a hydrogen electric powertrain, because the lower fuel cost of the battery electric powertrain, because kind of electricity is an input to produce hydrogen, so hydrogen will always be more expensive than battery than electricity. That kind of fuel cost benefit gets offset by the cost that you get by cycling through the batteries. And similarly, on the emission side, you see a similar story, that the main emissions, of course, come from the production of the powertrain, because in flight or the production of the fuel is close to zero emission. But in the production of the powertrain, so the fuel cell system, the hydrogen storage tanks, which are carbon fiber, in our case, or the battery in the battery electric case, you can see that simply by cycling through the intensity of producing the batteries, hydrogen electric actually comes off a lot better if you do that analysis. And lastly, we think that hydrogen is simply a more attractive opportunity to start with today, because it is applicable in a very near-term market, and I'll show you that on the next slide. But it also has the potential to scale to larger aircraft as we move through the coming 10, 15, 20, 30 years. What we are working towards at the moment is what we call ZA600, so a 600 kilowatt powertrain that could essentially replace the engine in most of these aircraft here. So that is what we will go to the market with and our timeline towards certification is 2023. And as I just mentioned before, right, the way that this is interesting to the operators is because it does provide potentially lower fuel costs, lower maintenance costs. You have faster turnaround times than the battery electric case as well, potentially. And you have very low emissions from end to end. So where are we in all of this, right? I think some of you probably have seen some videos of our flight tests in California last year before we set up our operations here in the UK, and the beautiful Piper aircraft here in the UK now as well. That you see in the middle picture, we have a hydrogen fueling truck actually fully up and running, and we have a hydrogen test lab established now in Cranfield that we can be starting to use now as the university lifts their restrictions. And as soon as kind of now post-COVID everything becomes operational again, we're planning to start the flight testing in the first half of June. So that means by the next time the Foresight Aerospace conference comes around, I'll show you flights of the UK and no longer the ones in California. All of this is funded by the UK government and the Aerospace Technology Institute in the High Flyer project, where we work together with EMEC and Intelligent Energy. And that will culminate by the end of this year in a long distance demonstration flight from Kirkwall up in the Orkneys, where there's already a lot of renewable hydrogen existent, from there down to Edinburgh most likely. And we will look forward to sharing the results of that then with the wider audience here as well. Now, before I bring up the bet again that I ended with earlier, let's look again at timelines that are a bit further away than mid-decade. So I spoke to you about our first commercial offering right in 2023 in the 19-seat category, CS23. But we do very much believe that there is a role for hydrogen to play in the larger airframes. And when you listen to some of the statements that have come from the Airbuses and Rolls-Royces recently, I think the industry is slowly aligning itself to that vision as well. And so with that in mind, I would like to end this short presentation. Please reach out to me if you have any questions, if you want to go through some of these numbers yourself, if you want to see some of our progress yourselves. And maybe we can actually put up my last bet again now to the screen, Eric, if that's possible, and we can see if you actually believe, just like I do, that we can actually fly zero emission, at least across Europe by 2050.
Right. So I think, thank you very much for that, sir. I think okay, so the results are coming in on your last bet. Bet with or against Julian, will Helena fly to her hen do on a zero emission aircraft? And I think 86% saying yes so far. We're only about halfway through it.
I'll take that. I convinced sufficient people. That's good.
No, that's brilliant, and we'll let that play out, and we'll get back to that a little later, maybe at the end of the day when the poll is closed on that. So, thank you very much, sir. That's absolutely fascinating.
Thanks, Daryl.
Cheers. Right. Okay. So right now we've got Nikhil Sachmeda, and I failed in my. Here we are. I'm just going to promote Nikhil, and hopefully Nikhil will be joining us just shortly. Who's going to be taking us through how the aerospace industry will adapt. I'm eagerly waiting on this because I've seen pretty much all of Nikhil's stuff, and it's always really interesting. And I have a couple of questions for him later during the panel session. So, Nikhil, sir.
Hi, are you able to hear me?
Yes, we are.
And the video as well. Perfect. Thanks very much, Daryl. Pleasure to come back to Foresight Aerospace speaking this time as well. And you should be able to see my screen in just a second. How's that? Perfect. Thanks very much. Okay, well, first of all, thank you, Eric, for putting this together. and thank you, Daryl, for supporting again, despite these very, very strange times that we're living through. So next few moments, I'll do my level best to follow the great acts that we've already seen today, but hopefully coming at it from a slightly different angle, really much more reporting on what other people are doing, but hopefully in a helpful and insightful way. So first, just to talk through the various technologies that are being explored to make aviation sustainable. We've already heard about them all today, but we'll cover them in a holistic sense in just a second. Then a bit of a deep dive into electrification, because obviously that is a particular area of focus. And then just a little bit on the impact of COVID, where I fortunately managed to secure all the results from the poll that was held earlier today. Thank you to 77 people who filled out that poll, and you'll see the results in that section in just a few minutes. So first of all, let's just address what we've already heard from a number of different people today. The reality is that there's no one obvious solution to how aviation can be made sustainable. But there's probably three categories of solutions, right? So we have novel fuels, let's call them, if we just bucket all that together, there's a lot of activity within sustainable aviation fuels. Graham Cooper was talking about ammonia as well earlier today. I think I'd bucket it in there, even though it's not specifically called out. You have electric solutions, which have various levels of hybridicity, but obviously eventually going to an all-electric solution, such as the battery. And then you have hydrogen, where just as Julian a moment ago was mentioning, there's the hydrogen fuel cell option, which is actually a combined electrical and hydrogen solution. Or theoretically, you could also have hydrogen combustion. Now, each of these offer a solution to CO2. So sustainable aviation fuels will remove CO2 in a net zero kind of way. Different levels of hybrid and eventually battery electric would completely eliminate CO2, and hydrogen as a fuel would also eliminate CO2 in terms of the emissions in operation. But just considering the difficulty of each of these for a moment, SAFs, though broadly compatible with today's engines, given some tweaks in fuel delivery and combustion, electric, you really have to rethink a lot of the aircraft, requiring novel engine architectures, obviously, brand new powertrain, or indeed a merged powertrain if it's a hybrid. So you have gas turbines as well as electrical systems. But then ultimately, to really eke out all the possible benefits, you need to bring in distributed propulsion as well. And thereby you need novel aircraft architectures, not to mention volumetric requirements for batteries, which are not negligible. And obviously electrical systems, thousands of volts that we've never flown at that altitude before, and performance that we've never really had to test before. Now, hydrogen, interestingly enough, you can genuinely have true zero, as I call it, solutions as well. But the challenge there, as we've heard already, is more volumetric. From a gravimetric density perspective, hydrogen is fantastic. There's no doubt about it. It beats conventional fuel. It certainly beats batteries. But even adjusted for volumetric density, you can argue that as a storage mechanism for energy, it would beat batteries. But then there's other challenges as well, such as power electronics, and of course, storing this thing in an effective manner. Now, with all of this in mind, let's just take a step back, because I think throughout the day we've mainly spoken about carbon. We have touched upon other effects, other greenhouse gas effects, but I just want to spend a moment here because this is a challenge which I wish was, let's say, discussed even more, and therefore I'd like to spend a few minutes on it. Depending on the estimate that you really believe, the total impact of aviation's radiative forcing footprint, so really its impact on global warming, could be anywhere between 2 and 6 times as much as just the carbon portion. Now, carbon is obviously the longest lived greenhouse gas. There's no doubt that if you look at all of human emissions, all of greenhouse gases ever created, carbon is the main problem. But with aviation, you have to consider all of these other emissions. You have to consider all of these other very different mechanisms by which how these are all produced. Carbon, you can't really escape it. It's the number of carbon atoms you're burning, and in an atmosphere in which you're burning it with oxygen, you're going to end up with CO2. It's very deterministic. NOx is not as deterministic. It's more of a function of the temperatures that you achieve in combustion, as well as the degree to which you have lean burn versus rich burn in your combustion chamber. Now, water vapor, again, it's kind of a result of combustion, but it can be managed. And then you have sulfates and soot, which over time, over the past several decades, we've actually been fantastic at reducing. If you think back to Boeing 707 engines, many of you will have seen the aircraft. I certainly haven't. Thankfully, I've seen many pictures, but you know, it's black plumes of smoke coming out of the back of those engines. And we've been very good at reducing all that soot, as well as other particulate matter. But unfortunately, the contrails picture is not something we've been able to sort out as yet. So how do each of our technologies address these different types of emissions? Sustainable aviation fuels are great at creating a carbon cycle. By recycling carbon itself, you, in essence, remove carbon from the combustion process. It is, of course, still produced. You still create CO2, but assuming you have an efficient production and supply chain, and you are able to use 100% SAFs in operation, you do have an effective carbon cycle there. But the NOx, as well as the water vapor and contrails and aviation-induced cloudiness, you unfortunately don't eliminate those. You may see reductions in those due to various factors, which we can go into separately, but you still have all of the other effects. So if we take the most scary estimates, we could still have around 80% of our radiative forcing if we only use SAFs. Now, electric propulsion, it depends on how hybrid you are or how electric you are. If you have a parallel hybrid with a 10 to 20% reduction in fuel burn, well, you will get a 10 to 20% reduction across the board with other greenhouse gases. If you are able to go to a pure battery electric aircraft, which would be, let's say, a gold standard, you can actually eliminate all of these greenhouse gases during operation. Not considering, of course, manufacturing of the batteries, manufacturing and mining the materials. That's a separate piece outside of what this slide is covering. And hydrogen, as we've said, CO2, and for hydrogen fuel cells, NOx is removed as well. But water vapor actually increases, and depending on how the aircraft are operated, you can eliminate contrails and you can eliminate aviation-induced cloudiness, but it requires a very careful grasp and very careful operation around weather effects. So one easy solution, in inverted commas, which could apply for smaller aircraft, like, for example, the Zero Avia, would absolutely work for this. You can fly just within the troposphere. You don't go into the stratosphere. Your contrails and AIC will be markedly reduced, or it could be zero depending on the day on which you're traveling. And actually, you do achieve zero emission travel on those days, or zero radiative forcing travel. Now, considering the technological barriers and the benefits here, if you were able to wave a magic wand and achieve whatever you wanted, then you would just go for all electric or possibly hydrogen fuel cell aircraft. If that's what you could do, then that's the ideal solution. However, it gets a bit more complicated because battery gravimetric density isn't quite there. Hydrogen volumetric density isn't quite there. And the kind of ranges and the kind of distances that we want to fly and the kind of sizes of aircraft that we want to consider for large commercial as the big question, as the big emissions generator within aviation, you need to be a little bit more broad in terms of your solution set. So Daryl, you like this chart. I know you've seen it from me before, but I think what might be new for today is what I'd like to bring and suggest for debate here to this audience is that we could consider three strategies. For the very short flights, let's say about 1,500 kilometers, maybe 1,000 nautical miles, depending on how you cut the picture. that's the era, that's the part of our flights that we could reasonably consider all electric for. And going to the opposite end, the very long distance flights, flying from London to Singapore, Sydney to New York, those kinds of flights, for them to become hydrogen or battery powered does seem like a real stretch, even by 2050. Even by then, it doesn't necessarily, we haven't fully understood how that might be possible. Certainly not sooner than 2050. And so what we're talking about here is maybe that's what SAFs are ideal for. Thus, no surprise that we would hear so much about SAFs from someone like Rolls-Royce that focuses on wide-body, long-distance engines. Makes perfect sense. But then in the middle, I think that's the battleground state. That's where we're not sure what the result will be. That we're not sure which technology will win out. It could be hydrogen fuel cells potentially. It could also be a good hybrid with distributed propulsion. So I think all electric has a significant role to play. Electric certainly has a significant role to play, even for the middle zone, which I'm calling strategy 2. And then over time, as these technologies develop, hopefully we can move these barriers forward, and you can address more and more with the better technologies, which are towards the left of the chart. So with all of this in mind, let's just deep dive a little bit into electric. I don't want to spend too much time on this. I think a number of you may have seen these kinds of slides before, but it's just interesting. We've been looking at how the announcements picture has been changing. We've been tracking announcements, as some of you will know, for several years now into electrically propelled aircraft, and North America and Europe no doubt are the front runners in this area, but Europe slightly ahead of North America, and actually the number of new developments since 2019 to now in Europe has actually also grown faster than North America. So there's something about our continent here that is, it just makes for a good environment for next generation aviation. As of last week, which is when we did this count, there's about 230 aircraft which say that they're going to be electrically propelled. But the interesting thing now is that actually, rather than the exponential growth that we were seeing into 2018, 2019, we've definitely seen a bit of a slowdown. Now, this is actually not the COVID effect. We'll come to the COVID effect in a moment, but if you deep dive into the quarters, we've actually been seeing a slowdown over kind of from the beginning of 2019 all the way to now. And it's a nice S-curve that we've actually achieved. It seems that the boom that we saw in urban air mobility predominantly, but also to a very large extent in general aviation, went between kind of late 2017 through to 2019. And we've been through that now. Now it's a matter of these developments actually coming to fruition. And it's fantastic to hear how many are getting close to their first flight. But now to the COVID effect. The interesting thing that we've also been following is whether or not this crisis, this existential crisis that aviation is going through and that aerospace is going through, will accelerate or decelerate the move to sustainable aircraft. And even though I think the mood in the discussion today, and I would argue that the audience and the presenters today are largely believers, right? So it's maybe a slightly skewed audience. I'm definitely one of them, by the way. I'd say, despite the many reasons why we've been hearing today that actually we could get to electric faster, we could get to hydrogen faster, there's a lot of reasons why we might be seeing a deceleration as well. We've had a descoping of the EFAN-X program already. There's probably a number out of that 230 that haven't officially gone out and declared it publicly, but are suffering financially quite significantly as investors might withdraw, as R&D funding from incumbents might slow, as they try to tighten their belt, right? And a key thing, I think, is a potential delay to the next generation large commercial aircraft as well. I mean, Boeing, given the 737 issues they were suffering, I think it was quite popularly thought that they might accelerate their next aircraft, the 737 replacement aircraft, to compete with the A321neo. Now, with the kind of issues, financial and otherwise, that they're facing, could we be seeing a delay to Boeing and indeed what Airbus does? And of course, when we look at oil prices, we could be from an aviation perspective, there's less of an incentive for aviation to reduce fuel burn, which is indeed one of the reasons people have been trying to become more sustainable, at least in the short and medium terms. But let's put all of that aside. Let's see what you had to say. So we had 77 respondents to these 5 questions. Thank you very much for responding this morning, and thank you, Eric, for sending me the results. And what we got was, interestingly, SAFs and hydrogen aircraft. So just looking at questions 1, 2, and 3 first, looking at the technologies, the sustainable aviation technologies. Electric is where everyone seems to think there will be an acceleration, which is really fascinating. Whereas, let's say the audience is a little bit less certain on SAFs and on hydrogen. But then considering questions 4 and 5, which are more about aircraft architectures, urban air mobility, yes, people are quite bullish on that. Again, no surprise given the audience, but the distinction here is quite interesting, that people believe that the intercity subregional transport aircraft, various sustainable types or various powertrain types will succeed. What I'd like to request, unfortunately, Zoom does not allow for comments in these polls in terms of why these are the votes that we got. So as a request to the audience, if you wouldn't mind putting your thoughts on why these things might happen, just anything you feel strongly about that you see on this chart, or that you noticed in the morning when you were actually filling out the poll. It'd be great to get your qualitative view to bolster this kind of quantitative picture. So I'm very hopeful that this is indeed the case, that COVID doesn't slow all of this down. We have 2030 targets to hit if we're going to hit our 2°C target as a species, as a planet, and we have 2050 targets to hit. And I'm very hopeful that the bullishness that we've seen from this audience actually does come to fruit. With that, I'd like to draw to a close. Back to you, Daryl.
Nikhil, thank you very much. And your chart dividing it into the 3 different sectors, I think, was absolutely spot on. I think that's what I was looking for you, and you did not fail to deliver. And I'll be sure to reference that in future presentations that I'm doing. So we're running a little bit over time. There's lots of questions in the Q&A area, so please feel free. Any of our panelists from today, feel free to put some answers to that. So I'm going to quickly transition over to Neil Cluffley, who's the Managing Director at Faradair, who's going to share with us some developments that are going on there. And the green screen is looking beautiful, sir.
Oh,
I'll pass it over to you, Neil.
I have to say, David Rotblatt gave me some great inspiration from the last time we were talking together. So this is what we're going to do now. When you commented earlier about what had happened with EasyJet, and you're thinking, is there anything else the aviation industry needs right now than another kick square in the provincials? And it is astonishing. So, but it is what it is, and it's what we have to deal with. And at the moment, aviation is getting a real battering. There's no doubt about that. And there is challenge there. There's an awful lot of people who have sadly lost their jobs, and it's one of those times that you never want to see. But as has been pointed out today, there are opportunities. And there are some really interesting times ahead. And so what we're going to do is focus a little bit here on some of the things that we've been working on, where we're looking for the future, what that means, and just give you a little bit more background of some of the stuff we've been doing. So what do we know? What do we actually know? And then sadly, unfortunately for Dr. Simon Weeks at the ATI, who gave a talk, the Templar lecture at Farnborough for the Royal Air Society in November, the exponential growth curve in commercial aerospace industry, all previous crises are just a blip. We know the curve is going to continue for the next 10 years. Hindsight's a wonderful thing now, and you look back and you think, oops, clearly not. We can never guarantee anything. That's the one thing that we definitely know. We know that we cannot possibly say that we're on exponential curves at this time. Something is always around the corner. And this has really highlighted a decline in the industry, unprecedented. I mean, it really is unprecedented. And I think it is going to have long-term effect. I think we're already starting to see it. And things like we have in the bottom left-hand corner there, the A380 parked up. That's in, I think, Northern Ireland at the moment, awaiting disassembly. That's a 10-year-old, $480 million asset with no home now being turned into parts. That's a wake-up call that's been coming for a little while now, and it's something that's really quite fundamental. Then, of course, we've seen a recent announcement about cancellation of EFAN X. And again, it's a case of, was it really the right project at the right price at the right time for the right objectives? And these are questions that now need to start to be looked at. Does it mean that it's a disaster for hybrid electric flight and everything else? No, I don't think it does. I think because now we need to reevaluate what we're doing, how we're doing, and who we're doing it with. And I think David Rotblatt's comments earlier about the industry as a whole coming together now and actually recognizing, okay, let's all get together now. Let's start talking about what we can actually do together and see where we promote this and where we push this through, because we believe that's the way forward. But what's the collateral? And the collateral really is this. And unfortunately, even when the Transport Secretary, who has supported and endorsed us, is turning around and asking people when they're going back to work to maybe avoid public transport because we've had to reduce the amount of trains and capacity, etc., then clearly we have an issue here. We have something that is going to force more people back onto cars. But if we're then closing down parts of the city for e-scooters, bicycles, etc., we're going to get more congestion and choke points in different areas, and etc. This is going to change the landscape of commuting on a daily basis for some foreseeable future. We are seeing pickup in air traffic now. I mean, it's really quite interesting to see, even just the last couple of days, the air traffic volumes picking up. But this is a problem that is going to have some long-term implication to our sector. So just talking about the air traffic, I took a snapshot on April 17th, 2020. I was just coming out the throes of being violently sort of hot, cold, and headaches and everything else with this potentially the virus. But that was the air traffic over New York on April 17th. And you can see, obviously, the commercial traffic is on the floor. There isn't hardly any. Some regional, and you can see some private aircraft traffic around and helicopters. And then I did the same exercise just the other day. So really a month later, we've seen, again, similar sorts of level of commercial aircraft, maybe a few more, but quite a few more private flights. And I think this is going to be an interesting thing now, and there's contradictory views. Some people think this is going to play into the hands of the low-cost carriers. I'm of the belief that I don't think that's quite the case. If people are going to be loath to stand in big long queues, you remember what it was like? The gate was getting close to announce you could get onto your low-cost carrier. Everybody starts queuing because they all want to get their hand baggage on. So now that people have got to stand apart, they've got to have social distancing, they've got to do all these sorts of things, you could end up in a scenario where a lot of people say, you know what, how badly do I need to make this trip right now? The business executives who really do need to make those trips and they need to make those face-to-face meetings, how many of them now are going to look at the business aviation market? How many of them are going to start looking at business jets and going, actually, there's 1, 2, 3, 4, there's 5 of us here. It's more than we would ordinarily do, but let's go and hire a jet and do our flight next. So that's something that may impact. So I think what we're looking at is a model where the flight models will change. And I think that regional is definitely part of that. As we discussed a couple of weeks ago, whilst we do believe that some of the hub and spoke comes back, there is also really interesting opportunity for point-to-point. And hybrid electric flight will give us that. But of course, we see lots of ideas, and Daryl mentioned earlier about the flying bathtub, and I'm glad I've got this one in there because that was quite good. We've seen vertical flight. We've seen all the ambitions from the 1950s to present day. It is the dream. It's what everybody wants. We all want to be able to just up and go, and that's great. There are a lot of challenges, as everybody's heard. You've got infrastructure, you've got networks, you've got certification, regulation. I mean, even with the idea of an aircraft that's a helicopter and an aircraft, and it flies between and transitions between those two phases, from the regulatory point of view, does that now mean that you have to have a helicopter license and a pilot's license? It's things like that. There's all sorts of things that start to make this still a very, very complex subject. But there are some glints and chinks of innovation and some bright ideas. So just in the last week, we have seen medical flights going across the Isle of Wight with a drone. And it really did bring a smile to my face because our family's been involved in the military UAV market and sort of 32 years ago. And bottom left-hand corner is a picture of the Swift 2, positioned at Thorney Island to take off over the Solent. And so we used to fly military-sized drones. And seeing that sector growing and seeing all the things that my father was talking about sort of 32 years ago coming to reality is a huge moment for me and certainly my family, because I think it proves everything he was saying was right. In the bottom right-hand corner, though, is the image that most people probably haven't seen. And this was pretty much the world's first combat UAV. And if you notice the V-tail pusher configuration, we had this sitting on the ramp again at Thorney Island there in 1990. We've done a lot of work with joined wing technology. And so to see this week again Embraer's announcement about their new pod-like aircraft that can transition from a road vehicle to an aircraft, and it's got joined wing tech, is obviously is great news. It's fantastic to see. But let's talk about our beastie. We've given an awful lot of presentations now over the last 6 years that we've existed. 2014, we started this journey. We started talking about hybrid electric flight, and we say bio because we've always intended the aircraft would fly on biofuel, SAFs. It can fly on Jet A, of course, but really the idea was that the aircraft is designed specifically for the powertrain, and it always has been. So when people are suddenly shocked and surprised that if they consider an all-electric regional flight to the Scottish Islands, for example, and suddenly realize that inclement weather may force you to go back and you don't have the range, hybrid was always going to be the option. And it's what we've been talking about for 6 years. So listening to Jean Botti and what he's working on is fantastic. I do wonder if I'd had Jean sitting alongside me when we first went to sit and talk to the ATI in 2015, whether we'd now actually have our aircraft sitting on the ramp ready to go. But that's the nature of the beast. Sometimes people may not believe you until they see it with their own eyes. But what we've got here is a workhorse. It's an environmentally neutral cargo commuter workhorse. So we announced this at Revolution Aero, and we basically revealed the fact that the work we've been working toward was a 19-seat airplane. Lo and behold, we now see Pipistrel now aiming towards the same target that we're at as well. And the aircraft has always got to have been a cargo passenger workhorse. The aircraft has got to do a range of roles and mission capability, and hence why it's always had the door, passenger cargo door. So we can carry 3 LD3 containers. Now, we've walked through the aircraft design. A lot of people have seen it with the 3 wings, and they go, oh, it's very draggy, and why do you... The aircraft is designed to carry a heavy payload, take off and land in a real short distance, and utilize the hybrid propulsion system. With hybrid propulsion, you have a whole range of issues in terms of, from the regulatory environment, getting the regulatory environment to consider, is a hybrid propulsion system engine a single propulsion unit, or is it a multi-propulsion unit? That's something that'll have to be worked out. Is it on a single lever operation, or is it on a twin lever operation? Can you switch between the two? Can you lock and engage both levers? That is something that is probably the challenging bit for the regulators to get their head around. The rest of our aircraft is a pretty standard aircraft. We operate in the existing airspace. We operate from existing airfields, but what we can operate from are a range of smaller airfields. So if in this post-COVID-19 world, we're looking at getting people out to those regional airfields, then maybe having an aircraft that can operate at pretty much every airfield would be an exciting prospect. And even areas that aren't considered as airfields right now. With 300 meters takeoff distance and carrying 5 tons of payload, we can take off and land, or will be able to take off and land from the new aircraft carriers for the Royal Navy, and also the aircraft fits within the hangar door of the carrier. And that's not by chance. So if you look at the operational capability, we intend to take a traditional turbine. So the primary flight thrust will be powered by the turbine, obviously connected to a traditional a propeller, but it's a prop fan. We then in contra-rotation use the electric propulsion, and we basically switch the emphasis between the power. So we can throttle back the turbine and boost it with the electric for the takeoff. And then basically the turbine then takes into the cruise mode, and the electric winds back. But by utilizing SAFs and biofuels as well, what we're really doing is trying to provide an aircraft that we can get into the market very quickly with proven, trust and tested technologies without massive infrastructure change. It's a self-charging hybrid. We don't need a whole bunch of new infrastructure at airfields. But what we can also do is once we finish flying passengers, we're then obviously able to take cargo and fly during the night and basically make as greater use of that asset as possible. And that's the key thing, is how much are you going to use the asset? So as we say, got a range of different roles capabilities. We sat last year with Secretary of State for Defense, and we were talking about opportunities for UK Armed Forces. Just before we got locked down, I was in the US talking with Pentagon officials about our military ideas. And of course, our civil applications. We're looking at opportunities where we can not only do passenger, but also other opportunities. So here we've got an aircraft that is traditional in the sense that it is a traditional airplane. It includes some innovative technology, some new materials, new propulsion methods, but really it's something that you can get your head around fairly easily, which is why one of our advisory board members, obviously Toby, when he first got involved and looked at the project, he's been involved in the certification and deployment of a 5th generation fighter and all the air assets, the carriers. And when he's had a look at it and thinks that we've got a really good opportunity, then obviously we're quite excited about it too. Awful lot of prototyping and testing work has been gone on. Obviously, we're building on the work we did 30 years ago with Joined Wing Tech. So we've done a lot of our proof of concept work a long time ago. But since then, we've been evolving from the original design we first came out with in the market, which was really more of a place marker, a holder effectively. And now moving forward to where we want to be, which is ultimately up to a sort of 19-seat sized aircraft. That work has been going at a pace as funding has permitted, which is frustrating. Had we had the funding support that we'd requested a long time ago, we may have the world's leading hybrid electric aircraft sitting on the ramp today. It isn't, it's what it is, and we've done the best that we can with the resources. So what are those resources and how have we done? Well, if you look at the contact level and support we've managed to achieve in government, we have the current Secretary of State for Transport has given his full endorsement and backing. We sat with Secretary of State for Defense and now Paymaster General and Cabinet Office, Penny Mordaunt, and the former head of the Defense Select Committee is also a huge supporter. And I released an article just recently, which is basically prime interest question mark on resilient aviation and the future of sustainable. And if you look, we obviously see interest there from GKN, Airbus, Rolls-Royce, Cranfield University, and that's a fairly familiar sign with a lot of the posts we make. Unfortunately, none of them have actually yet contacted us about the program, and it's something that we have found a real big challenge in this country, where Jean Botti has basically been able to get an awful lot of that support in France. We struggle with that. So to date, we have received 0 taxpayer funding in anything that we've done. It's been funded by angel investors, etc. But we've been pushing this story and this agenda with the aircraft now for 6 years. If anybody wants to question where the true pioneers of this vision for has come from, we were putting this before the Future Flight Policy Committee in 2017. And it is frustrating that we haven't gotten further. There is nobody more frustrated than I right now that we don't have the aircraft sitting on the ramp. And now we're facing with a situation with a pandemic, which has made the challenge even harder. But we are now getting interest from airlines and investors, especially from overseas, which places us in a really awkward position. Do you then pursue the opportunities and take the project overseas? Or do you do what you intended to do and try and fund and build the aircraft here in the UK? But if the funding simply isn't coming, because we keep, unfortunately, putting funding into projects like EFAN-X at 58 million, how on earth are we going to get some of these smaller aircraft projects up and going? We have got to have a rethink about how we are backing our innovative programs that have now proven themselves. And that's one of our most frustrating things we've got to deal with. But we're here. We're still alive. We're still going. It has been brutally tough. And this challenge has just added an extra element to it. But it's not something that we're going to not overcome. We have an aircraft here which is hugely exciting. We're doing on the flight numbers and the performance analysis we've done the simulation, it does things that other aircraft just don't do. But more importantly, it has been designed for hybrid electric flight. It will migrate to fully electric as and when the time is right, whether that's going to be full battery electric or whether that's going to be hydrogen electric, who knows? But that is where we're at. And we're looking forward to getting stuck into it as soon as possible. Thanks ever so much.
Thank you very much, Neil. And I have my noise meter for our standing bet on how noisy this little beastie is going to be when we do get to see her on the airfield. Right, so we're going to swiftly move into our panel discussion, and I'm glad to see that Nikhil has been able to stay on, and we've had Andre Bushberg join us, and I understand that it's just going to be audio, Andre, just that you're not in an area that has great mobile connection. I'd really like to kick things off with Andre. So you're the CEO at H55, and you've had a very interesting career playing with solar electric aircraft. Can you just give us a quick rundown of your history for the wider audience that may not be familiar with what you've done?
Sure, with great pleasure, Darrell. I apologize not to have the full connection, but I guess the 4G has been downgraded to something like 3.5 here, with a number of people connecting around all the Zoom meetings. You know, thinking back about when we started, which is already 17 years ago in 2003 with my partner Bertrand Picard, it was interesting. It's interesting to remember that, you know, when we presented the concept of having an electric airplane powered by solar energy, at the end is a hybrid technology. I was listening to what Neil was saying, and congratulations to what you do, guys, at Faradair. It was meant to be hybrid, as you know, using other type of energy source, but it was electric. And when we presented this aircraft for the first time was 2009, people said, you know, great technology, very very interesting, but no future. Unfortunately, things has changed. I guess things has changed because of a lot of reasons. I think the car industry or the Tesla type of experience has brought, I think, more understanding about what we can do with these technologies. But we learned when we developed the two airplane, we learned very interesting things. I mean, first of all, that's, you know, when you start designing airplanes using electric propulsion, of course, you pick up technology that you can get from different sources, mostly not, of course, from the aviation industry, which can allow you to fly a prototype, but to make it afterwards extremely difficult to certify. And that's the reasons why we had to develop a second airplane with basically a different architecture, different solutions, different systems to get closer to a certification. And I think that's why we decided also it's a point to set up H55. First, to focus on the only part of the technology, which is the electric propulsion or the propulsion chain, but above all, in fact, to be able to come up with certified solutions, certified systems to enable all the projects. I think you have been talking about hundreds of projects around the world with aim to provide these new solutions, to help them, I mean, to enable them to be able to come up with a certifiable new configuration.
Brilliant. I'm just kind of wondering if your opinion is that the industry is living up to what your expectations are in terms of electric propulsion. Do you think that we're doing everything that we can to support electric propulsion systems, or is there more that the industry should be doing?
Well, I guess much more, because a lot of the projects are developed by entrepreneurs, passionate people with limited funding. I was aboard of a new helicopter company which was aiming to come up with a new type of helicopter, but based on basically the existing configuration. Turbine as to provide the power, main rotor, a tail rotor. But bringing such a product to the market requires hundreds of millions of dollars to get the certifications. So I think what we'll be lacking and what we are lacking is really resources to make a big step forward. But thanks God we have a lot of motivated people around, so I think this will help to demonstrate the potential of these technologies. But then we'll have to scale up.
Right. Okay, Nikhil, referring back to your wonderful chart that you showed us in terms of the three different stages, and we've heard from VoltAero and ZeroAvia, and of course now we have Neil with Faradair and BEHA. I'm just kind of wondering if you were to talk about that first sector that you are looking in terms of electric and electric hybrid, and what kind of advice would you be giving to Faradair and ZeroAvia and VoltAero in that? is what they're doing supported by your analysis, or there are different areas that you think you could ask them to stretch into?
I think so. I think there's two questions there probably. So one is it supported by the analysis? Yeah, absolutely. I think so. That picture in which we have the curve and the three kind of strategies, that is, let's say, what's the art of the possible given what we know today, and including expectations in the medium term, let's say, where battery densities and hydrogen density and hydrogen volumetric densities storage could end up. That's not necessarily where we start. I think the kind of stuff that Neil is doing with Faradair and everything we've learned about Zero Avia, I think these are viable, commercially viable projects that they're working on, and they are exactly the right things to be working on today, which then can become stepping stone technologies for the future, 150-seater aircraft, which could then leverage, let's say, Neil's powertrain, in the next 15 years. And then that would be targeting, let's say, the middle portion of the chart, where about I think just from memory, around 30% of the emissions globally come from just that middle portion, right? Airbus and Boeing, ultimately, and to a much lesser extent, Comac, are ultimately the multi-billion-dollar beasts that need to be interested and need to invest. For companies who are brand new to build an aircraft at that level, and we know Zunum, to some extent, Wright Electric, they're targeting that level today in terms of, that's on their roadmap. For them to actually get there, that's a massive thing to achieve. So actually, I like the approaches that we've seen from Zero Avia, from VoltAero, and from the Faradair BEHA, because they're trying to build successful commercial business cases for their aircraft today. And so if there's any kind of advice as such from a consultant, as opposed to someone who's actually built an aircraft himself, it would only be it's about the commercial success. And if you can somehow marry together commercial success with a brand new technology, then the roadmap will open up. There's no need to necessarily stretch out that roadmap and show how you're going to be flying to Singapore 55 years from today. That's not where the value is. I think the value is building something that can actually achieve a viable business case today, fly to Manchester in 50 pounds, that kind of thing today. Fantastic. And the roadmap will reveal itself.
Brilliant. So Neil, obviously to respond to Nikhil's comment, but maybe adding on to it, I have the feeling that you're holding back on us in terms of what the BEHA can actually do, and maybe tease
we have
us.
To. There's too many big beasts around. We have to keep something back.
Well, I'm just interested. 300 meters, 5-ton payload. What could you do off of 500 meters if you stretch the fuselage and just variants like that? But I'll let you talk, and I won't try and steal any of your thunder or give too much away.
Yeah, I mean, we get told, and in fact, history is an interesting thing. I read just this week the struggles of Frank Whittle when he first brought the jet engine to the market. And he brought it to the Air Ministry, and the traditional view of the establishment was, no, old boy, go away. Mitchell faced the same thing. And it was, in fact, it ended up in the US, really. It was GE that really made that engine kick forward. And sadly, I think that if you look at our opportunity today, I mean, let's just take the UK, for example, and forgive me for the slightly UK-centric because it's easy to relate things to. But I could do the same from Sacramento to San Francisco or Manchester to London, as Nikhil just said. But if you think of Middlesbrough to London, if you think Liverpool, you think of Newquay. I mean, we've just lost Flybe. And there was a POS flight, a public service flight that went from Newquay to Heathrow. People need connectivity. If you want to go from Cardiff to Anglesey in the north of Wales, it's a 4.5-hour journey. It doesn't need to be. We can be doing something now. We can be delivering something now, which is what we've been trying to say for such a long time now. But it seems that unless you have got, as Nikhil refers to, one of the big beasts giving you the papal blessing, you don't know what you're talking about. And why should we put money at you? It's a huge risk. You've not done this before. You're a tiny company, etc. some of our greatest innovators in aerospace have taken the biggest risks. I mean, fair play to Andre and the guys at Solar Impulse. When you look at what they did with that aircraft, I mean, it was just astonishing. That's what you need. You need people to say, we're going to do this. I mean, if you look at Vertical, Christ, I mean, if I wish I had the backing and the money of an energy millionaire behind us to do what those guys have done. What they've achieved in a short space of time has been phenomenal. And I think this is what we've got to do now. We've got to realize that we don't need to spend £100 billion building an antiquated rail network to link certain cities when we've got it sitting right here, right now, deliverable within 3 years, where we could genuinely start linking cities across the whole country and in other countries. India, China, America. I mean, 5,000 airports around the US that could be linking regional point-to-point services that have never had a scheduled service in their history. Mm-hmm. This is the market we're talking about. It's massive, but we can deliver it now. And the beautiful thing about hybrid, and this is what people say, I had somebody say to me the other day, I don't see an opportunity for hybrid. If we looked at a Pilatus, it was a single engine turbine went down. It was had 4 SOCOM operatives on it a few years ago. And the problem is, once you lose your single engine, you're coming down. That's it. The ability to have hybrid propulsion means that you may have then a period of time where you have controlled powered flight to put the aircraft down somewhere safely. But more importantly, if you're able to eliminate all of that fuel burn, all of the emissions, all of the noise of that full turbine up takeoff moment by boosting or supplementing it with the electric and then switching it, what is there difficult to understand about that? I mean, that to me is just a no-brainer that we should be doing. And it's what we've been pushing for a long time. And that just opens up opportunities. So if it now becomes the norm to fly from Dublin to Norwich, or Cambridge, and there's a flight that does that. Oxford Airport, a fabulous little airport, Staverton, etc. These airports can become great little regional hubs where you could now go to Bruges from Biggin Hill. And you'd never thought of doing that before. We've got Manston now sitting there. The government isn't quite sure what it's going to do with Manston. There's a development group that's taken over and would like to bring cargo in there. There's your regional flight hub right there. You can put aircraft straight into Manston. So the case is obvious. The opportunity is obvious. The lack of requirement for massive spending on infrastructure means this is obvious. Let's get on and do it.
If I may add something on both what Nikhil and Neil has been saying, which I fully share, some kind of step-by-step approach, starting maybe with more simple applications. I'm a full supporter of this, and in some ways that's what we try to do as well at H55. Just to remind you, we don't design aircraft, and we focus on electric propulsion, and we believe that the first application which makes sense very short term is the flight trainer. It's the airplane which teaches young pilot students to take off and land, doing all these circuits all day long, so making a lot of noise, creating nuisance in the airports. Typical a flight mission of an hour, which can be done with existing electric technologies today, without waiting to have better batteries in the future. So we decided basically to go for this first application. It's a VFR application. Initially, it's a DVFR, day VFR even. So the level of certification is a little bit simpler than if you go for night or if you go to IFR. And the goal is to get our TC by the end of next year. We are well engaged with EASA to achieve that. And it's clear also that if you want to do other applications which are commercial transport, I mean short distance, I also fully support the idea that it has to be hybrid, and it will be hybrid for some time. We're also working on this. Solar Impulse was hybrid, as I mentioned at the beginning, using photovoltaic as the generation of energy. It can be Foresight for a while, will be potentially hydrogen in the future, but there's certainly also a path to follow. but it's already a little bit more complex path because if you are full electric, you have an electric motor and you have batteries. If you are hybrid, you add something else on top of it. And that's reasons why we see it more, in fact, in the second position. But of course, it's a necessity if you want to fly a little bit further. So step by step, from simple to complex, learning to do the certification path. And I guess EASA, the FAA have to learn as well. And showing that there are applications which works and which are economically extremely interesting, and providing what people are looking for, less noise and lower CO2 impact.
Brilliant. I absolutely agree. I'm kind of curious what you think about Harbour Air and their approach to electrifying 60-year-old beavers, and I think they're powered by, was it Magni-X propulsion systems? Just gents, I'm curious to get your view on their path.
But first of all, I really support everyone working to try to bring solutions with this vision in mind. So I think we each will learn, and these lessons will help us, I guess, all to get to ultimately to our destination. I'm not sure if I would have basically taken the same platforms, but they certainly have good reasons for that. They have short flights, so pretty appropriate for this technology. Let's see. I think Magni-X has a very interesting technology as well, and I think only through developing application, only by flying, will be having the experience necessary to get this product on a commercial level. We need data. We need data on all the technology, on all the systems, the electronic boards. They have to demonstrate that they are safe, and it can only be done if we are in the air as much as we can.
Nikhil, I don't know how much you've looked at Harbour Air. Do you think that they have an interesting path forward?
I do, but I think Harbour Air, I'd almost say that path actually belongs to Magni-X, as much or if not more than Harbour Air. I mean, Harbour Air is an airline. They're obviously leading. I think they actually went net zero using carbon offsets in 2008 or something. Mm-hmm. So they're really a front runner. They're really out there, which is fantastic, right? So, but I like the idea, and the way I kind of think about it is, it's iterative. So just like Andre is saying, it's a step-by-step approach. The first step in the iteration is you transform just the powertrain. The second step in the iteration can then be you extract the new powertrain that now you have proven works, and you wrap a new skin around it. Right? That becomes a new aircraft. And then you keep going again and again and again until you actually achieve some kind of optimal. And I mean, the alternative would be to go all out and create a brand new aircraft and brand new powertrain all at once. But from a certification perspective, I think the approach that Magni-X and Harbour Air have taken is actually really interesting. It's different from what a lot of other people are doing. Arguably, a similar thing is being tried by Aerospace with their Brittany Norman demonstrator, in which they're just converting an existing aircraft. And there's a few others that are taking that kind of approach in which they change out the powertrain. But I think it's a good approach to at least solving some of the challenges, keeping some of the unknowns controlled for, let's say, in the experiment.
Mm-hmm. Mm-hmm. Neil, I remember some of your earlier presentations, you were looking to develop your own powertrain with one of your development partners. What's happening in that, or have you switched to an existing powertrain? Because we talked a little bit about your slides.
Yeah, we obviously we were putting forward the notion that Zero Avio were putting forward sort of 3-4 years ago. Using a 6-seat aircraft, putting a hybrid electric propulsion system on it. It was a partnership with ProDrive called VoltAero. Mm-hmm. And it would have been that step-by-step process. And we were told, unfortunately, the funding structure wasn't able to support a project like that. Yet here we are today looking at exactly that thing, which is, again, frustrating. But we always knew where we were going with our aircraft. And as I said, there were certain placeholders marked for us where we knew that we would put a certain amount out. We knew that people would react to what we're doing, which 9 times out of 10 they did. So if we said it was an 8-seat aeroplane, there'd be a 9 or 10-seat appear 2 months later. But we were always working towards the big beast. And there is no way we were going to develop our own propulsion system for a 19-seat airplane. Never going to happen.
Yeah.
So I love what Roe's doing with Magnix. I think what they're proving is, I think they've got a Cessna Caravan now, just about ready to take flight, which is great. So now we're getting newer. So rather than it be a 65-year-old aircraft now, we're a 50-year-old aircraft or whatever. It's getting newer, which is great. But yeah, they're proving that the technology works. They're proving the infrastructure around that technology is working. And then if, from our perspective, if we're combining what we say is more the traditional power plant that we need for our aircraft, combined with some of that type of architecture, it's that little bit of the glue in between, which is what we know we can make work, because we've got partners that have done that in existing, either in automotive or in other fields. So yeah, our focus really is more on the aircraft. We're very, very keen. And I mean, this is the classic gateway scenario. If you took the notion of EFAN-X and the principle of that propulsion system, stick it in the back of our airplane. It's a 19-seat airplane that for a 1 megawatt to up to maybe 2 megawatt, depending if you want to do a cargo mission, then let's not waste what money has been spent by the British taxpayer on that. Let's put it in something and make it work. That would be sensible to me, but it's not my call. And there are others that will know whether it becomes a call or not. But that's what we've got to do now. And I think what David was saying earlier, and I think that the fact that the people at Airbus and Boeing and these guys are realizing that they have got core projects. Rolls-Royce, it's the Trent 1000 and the new fan that they're working on for new aircraft. That is their core bread and butter business. What they should then be doing is putting their arms around ventures. And yeah, an electric sport plane that goes and breaks a record, great, fabulous. What are we doing for the actual commercial market, which they've actually got a connected relevance to? That's where we really do now need to start looking at companies like that to say, let us go and do this stuff quickly. Let us do it on a cost basis that you couldn't possibly match if you tried. And if we all do what we say we're going to do, you've now got an opportunity to then scale that up into the bigger markets. That's where the opportunity is. And that's what we've really got to drive now. But it requires a number of people, the likes of the ADS, the ATI, the AGP, all the usual suspects in the UK, for example, but then the FAA relating to the EASA and all the other bodies to start working out this common architecture for example, which battery types are we going to use in the next 5 years? I don't know. I don't think anybody does, because the regulation hasn't been written yet. What are those companies going to do to now really embrace the innovators and get them the support, start pushing stuff through, so that when this market recovers, and it will recover, this aviation market will recover. When that's recovered, we're ready to go. The aircraft is on the ramp, ready to start flying people. That's what we've got to do. Again, it seems like a no-brainer to me.
Great, Nikhil. I'm gonna start to wrap this up. So I'm gonna ask for last quick comments. So we'll start with Nikhil, Andre, and then we'll have a last word from Neil, and then we'll move on to our next speaker, which I believe is Jenny Gardner. So I'll bring you up in a minute, Jenny, if you're listening. So Nikhil, please.
Thanks, Daryl. I think as a parting comment, just to go back to one of the slides I had in my presentation, we need to remember that one of the key benefits that we're bringing by considering all these new aircraft, by considering all these new powertrains, is that we are making the world a slightly better place, slightly more sustainable, slightly better for our climate. And I think in terms of the argument that we hear, and I've certainly heard for the past several years that I've been following and kind of working in this area, I think there's a supply side to the argument and there's a demand side to the argument. So the demand side to the argument is the distributed aviation piece that we've spoken about so many times. There's all these point-to-point pairs, the kinds of flights that Biggin Hill to Bruges kind of example, in which there probably is
all the bees.
Exactly. There probably is demand which isn't being served today, right? So there's definitely a demand side to the argument in this distributed aviation kind of world that we could unlock. But on the supply side, there are aircraft that could do that journey today. They're just not very good. They're just not very, they're not cheap. They're not cheap enough. They're certainly not good for the environment. They're not efficient, and they don't make for a good business case that would actually bring some kind of resurgence in that side of the market. So I think marrying these two things, we're doing what in commercial speak, we're making a market that doesn't exist, because you're bringing that demand and that supply together. And I think that's something that people actually putting money into this need to understand, that they don't necessarily fully understand from at least the conversations I've had. So yeah, that's the last kind of parting comment I would have. It'll be good if those who actually have the pounds and the dollars and the euros thought about it from that perspective, and that's certainly what we as consultants try to make do.
That's brilliant. Thank you, Andre.
I hope you can hear me, because my connection was not very good on the inside. Two comments. I think first of all, as the technology was emerging, a lot of companies had to do everything. And if you look at the VTOL world, that's a little bit the feeling you get, is that people are trying to come up with a new configuration, developing new propulsion, new motors, new battery systems, new autopilot, new way to fly. And if you add all these challenges, it's incredibly big. And it can only be, I think the result can only be positive if we slice it in small pieces. And I agree with Neil that, on one side you have people developing technology, but using existing platforms, the Caravan or whatever. I mean, we work with aircraft manufacturers who already have extremely good flight trainers as airplane structure using combustion engine that we can now transform into electric. And then we have people who come up with new configuration, because I think the potential of the electric propulsion is going to be very interesting if we use it well. And this needs and give the possibility to come up with new designs. So it's great that you have people who focus to come up with the development of a new configuration which can take and get all the advantages of this electric propulsion. Now, we hear a lot about, of course, big motivation to reduce the CO2 footprint, making the aviation industry greener. I think, as it has been said, I think a big demand will not come up from this directly. We have to make sure that we have great products which provide advantages and clear advantages, commercial advantages for the users. So just simply, I would say, replacing a combustion engine by electric propulsion will not make it. It will help to understand how to do it, but it will not make it. The offer has to be valuable. It has to become a cheaper way of mobility. The noise reduction has to be important as well, and through this, in fact, this technology will find its way into the commercial world.
That's brilliant. Thank you very much, sir. And Neil, last minute to share with us your thoughts on the industry.
We need a mindset shift. We have the City of London in the UK is one of the biggest wealth generation centers in the world. If you picture somebody like Rivian that went to the US, they've secured 500 million of support from Ford. They've now got the Lincoln electric car brand development program, mainly British motorsport and automotive engineers behind this project. There is just no way this type of project would happen today in the UK. It wouldn't happen. And you look at what Sweden are doing to support their sustainable aerospace startups, Germany, etc. We're starting to see in other countries the fact that nations are supporting projects that have got this vision that we need to be doing things bigger, brighter, clearer, cleaner, quieter. Unfortunately, that may not necessarily have to include a tier 1 prime involvement. It would be great if they did, but it may not have to be. It may not be a mandatory requirement. And I think at this moment in time, we've got to be able to look at projects on their merit value alone and their proof of concepts and all the work they've done and say, can we now, with fair security, say, this is the future direction where the market's going? Does that necessarily mean we need to put electric motors onto an aircraft that first flew in 1965? Maybe not. That's been proven. Magnets have done it. They've shown it. Let's start now looking at what do we actually enable the public to get on board that enables them to start linking across the country. And what you're talking about there is a social mobility shift. If you can genuinely commute to London for 50 quid and you could do it in under an hour, you have now opened up a vast swathe of a city in terms of where you live for cheaper costs, better quality of lifestyle, less crowded schools, all of the benefits of the fact that people commute within the strike zone of their city within an hour, because that's where they don't really want to travel more than that. But if they could now travel several hundred miles quite easily and effectively with a proven aircraft that can fly in all weathers and isn't sustainable to all the others, that is something we have to look at. We have to start looking at that now. And if we can do that, that means we've got to go today. We've got to back the ventures that have been around and proven themselves today. And let's get these things into the air by the next 3 to 4 years. That's where I think we should be. And if everybody else believes that we should be there as well, then you know who to contact, you know who to badger, and you know who to fight on our behalf. Because if you do it, I promise you, if somebody had given us the pot of money that was given to EFANX, in 3 years' time, I'll put an aircraft on the ramp ready to go. So that's my challenge to them. Back us, we'll make it fly. If not, let's chase around an aircraft that's been flying for 4 decades. That's my thought.
Right. Thank you very much, Neil. Again, I'd like to thank all my panelists and speakers for that session.